Hello friends, my name is Ramasu. Today we shall discuss about a topic, the introduction to Hadoop. Friend, today's topic is very interesting, especially if you have interest in Hadoop software. So what it is actually, how it works. So this is a very interesting and important topic for you. So let's just start, friend. First of all, I would request to please subscribe to my YouTube channel and click on the bell option as well, so that my new videos can reach to you. And also you can follow me on the Facebook page and Instagram as well. So let's start, friend. What is actually Hadoop? Hadoop is an open source distributed processing framework that manages data processing and storage for big data applications in scalable clusters of computer servers. It's at the center of an ecosystem of big data technologies that are primarily used to support advanced analytics initiatives, including predictive analytics, data mining, and machine learning. Hadoop system can handle various forms of structured and unstructured data, giving users more flexibility for collecting, processing, analyzing, and managing data than relational databases and data warehouses provide. Hadoop's ability to process and store different types of data makes it a particularly good fit for big data environments. They typically involve not only large amounts of data but also a mix of structured transaction data and semi-structured and unstructured information, such as internet click stream records, web server and mobile application logs, social media posts, customer emails, and sensor data from the Internet of Things (IoT). Formerly known as Apache Hadoop, the technology is developed as part of an open source project within the Apache Software Foundation. Multiple vendors offer commercial Hadoop distributions, although the number of Hadoop vendors has declined because of an overcrowded market and then competitive pressures driven by the increased deployment of big data systems in the cloud. The shift to the cloud also enables users to store data in lower cost cloud object storage services instead of Hadoop's new sake file system. As a result, Hadoop's role is being reduced in some big data architectures. Hadoop and Big Data. Hadoop runs on commodity servers and can scale up to support thousands of hardware nodes. The Hadoop Distributed File System (HDFS) is designed to provide rapid data access across the nodes in a cluster, plus fault tolerant capabilities to applications can continue to run if individual nodes fail. Those features helped Hadoop become a foundational data management platform for big data analytics uses after it emerged in the mid 2000s. Because Hadoop can process and store such as wide assortment of data, it enables organizations to set up data lakes as expensive reservoirs for incoming streams of information. In a Hadoop data lake, raw data is often stored as is so data scientists and other analysts can access the full data sets. If need be, the data is then filtered and prepared by analytics or IT teams as needed to support different applications. Data lakes generally serve different purposes than traditional data warehouses that hold cleansed sets of transaction data, but in some cases companies view their Hadoop data lakes as modern day data warehouses. Either way, the growing role of big data analytics in business decision making has made effective data governance and data security processes a priority in data lake deployments and Hadoop system in general. Components of Hadoop and how it works actually. Friend, the core components in the first iteration of Hadoop was map reduce, HDFS and Hadoop common, a set of shared utilities and libraries. As its name indicates, map reduce uses map and reduce functions to split processing jobs into multiple tasks that run at the cluster nodes where data is stored and then to combine what the task produce into a coherent set of results. MapReduce initially functioned as both Hadoop's processing engine and cluster resource manager, which tied HDFS directly to it and limited users to running MapReduce batch applications. That changed in Hadoop 2.0, which became generally available in October 2013, when version 2.2.0 was released. It introduced Apache Hadoop Yarn as new cluster resource management and job scheduling technology that took over those functions from MapReduce Yarn, short for yet another resource negotiator, but typically referred to by the acronym alone, ended the strict reliance on MapReduce and opened up Hadoop to other processing engines and various applications besides batch jobs. For example, Hadoop can now run applications on the Apache Spark, Apache Flink, Apache Kafka, and Apache Storm engines. In Hadoop clusters, Yarn sits between HDFS and the processing engines deployed by users. The resource manager uses a combination of containers, application coordinators, and node level monitoring agents to dynamically allocate cluster resources to applications and oversee the execution of processing jobs in a decentralized process. Yarn supports multiple job scheduling approaches, including a first in, first out queue and several methods that schedule jobs based on assigned cluster resources. The Hadoop 2.0 series of releases also added high availability and federation features for HDFS, support for running Hadoop clusters as Microsoft Windows servers, and other capabilities designed to expand the distributed processing framework's versatility for big data management and analytics. Hadoop 3.0 was the next major version of Hadoop, released by Apache in December 2017. It added a Yarn Federation feature designed to enable Yarn to support tens of thousands of nodes or more in a single cluster, up from a previous 10,000 node limit. The new version also included support for GPUs and erasure coding, an alternative to data replication that requires significantly less storage space. Subsequent 3.1.x and 3.2.x updates enabled Hadoop users to run Yarn containers inside Docker once and introduced a Yarn service framework that functions as a container orchestration platform. Two new Hadoop components were also added with those releases: a machine learning engine called Hadoop Submarine and the Hadoop Ozone Object Store, which is built on the Hadoop distributed data store block storage layer and designed for use in a on-premise system. Hadoop importance to user. It can store and process vast amount of structured, semi-structured, and unstructured data quickly. It provides application and data processing against hardware failures. If one node in a cluster goes down, processing jobs are automatically redirected to other nodes to ensure applications continue to run. It doesn't require that data be processed before being stored. Organizations can store raw data in HDFS and decide later how to process and filter it for specified analytical use. It's scalable, so companies can easily add more nodes to enable their system to handle more data. It can support real-time analytics to help drive better operational decision making as well as batch workloads for historical analysis. Hadoop applications and use cases. Yarn greatly expanded the application that Hadoop clusters can handle to include interactive queuing, stream processing, and real-time analytics. For example, manufacturers, utilities, oil and gas companies, and other businesses are using real-time data that's streaming into Hadoop system from IoT devices in predictive maintenance applications to detect equipment failures before they occur. Fraud detection, website personalization, and customer experience scoring are other real-time use cases. Some other common use cases for Hadoop include as customer analytics. Examples include efforts to predict customer analyze clickstream data to better target online ads to web users, and track customer settlement based on comments about a company on social networks. Risk management. Financial services companies are use Hadoop clusters to develop more accurate risk analysis models for use internally and by their customers. They also build investment models and develop trading algorithms in Hadoop based big data systems. Operational intelligence. For example, Hadoop can help telecommunication companies better understand switching performance and network and frequency. Utilization for capacity planning and management by analyzing how mobile services are consumed and the available bandwidth in geographic regions. Telcos can also determine the best places to locate new cell towers and respond more quickly to network problems. Supply chain management. Manufacturers, retailers, and trucking companies use Hadoop systems to track the movement of goods and vehicles so they can determine the cost of various transportation options. In addition, they can analyze large amounts of historical time stamped location data to map out potential delays and optimize delivery routes. The technology has been deployed for many other uses as well as, for example, insurers use Hadoop for applications such as analyzing policy pricing and managing sale driver discount program. Also, healthcare organizations look for ways to improve treatments and patient outcomes with Hadoop's aid. So, friend, thank you. Thanks a lot for watching the video. I hope you like this video. If you like it, please share it with your friends and colleagues. And thanks a lot for watching the video. Thank you, friends.